Good afternoon, everybody. Thanks for showing up for the last session of the day. Compared to my colleagues who were talking about all the machine learning and artificial intelligence that we do at Amazon, I might have the less colorful slides, but I'm talking about how you can run your enterprise workloads. So the title of this presentation is Getting Started with Containers in the Cloud. My name is Frank. I'm a DevOps engineer, software architect. I work for AWS as a technical evangelist. And what I want to do in the next 45 minutes is talk to you about containers, talk to you about microservices, then explain you a little bit how you can run your microservices in containers on EKS, which is one of our container management services, then talk about EKS, and time permitting, talk about service meshes and CNCF projects that run on top of EKS. Now, let's do first things first. And usually we do a demo at the end of the presentation. And if we talk about containers, very often we talk about isolation versus virtualization. And we try to explain what namespaces are in Linux. We talk about resource limits, and we try to explain what C groups are. We talk about the fact that those containers are sometimes very transient or volatile. They disappear, and we have to care for this. And then we like to mention that they provide an extreme scale, so they scale extremely well. And very often you see this in PowerPoints, and I thought since you've seen so many PowerPoints already, I'll try to show you this. Hopefully less than 10 minutes, and then we switch back to the slides. So, okay. This is a shell on my local laptop, and what I'm doing is I'm connecting to the cloud. That's an EC2 instance running in the cloud. It's actually running in Frankfurt. And that's the remote instance that I want to use to show you a little bit about container concepts. Now, if we want to start a container, we say Docker run. Now, what I want to do is I'm running an EC2 instance, which is running under Amazon Linux. And what I want to do is under Amazon Linux, I want to start another container, which is using another Linux. So I say Docker run CentOS. And on this CentOS, I want to say, who am I? And it responds with root. So this container is running as root. The interesting thing here is I run a different Linux, but I never boot it up. I never have to wait until it gets started, because it's a container that is that is using the kernel that we already have for running the Amazon Linux. Now, let's try something else, and let's run a container which is running in the background. This is why I give it this -D switch for a daemon. And it needs a port mapping. And actually, it's using a port 4x9, and I want to map this 4x9 port. It's running under my account, so you can find it on Docker Hub if you want to replicate this little exercise. You could do it. And the container is called micro, because I was paying a lot of attention to make it small. Now, this container is running now in the background. And if I try to talk to it, if I say curl localhost 4x9, it's responding. So it sends something back that looks almost like a web page. And if I find my IP address that looks like this, and I try to access it. Now from here, from my laptop, and I give it 4x9, you see it's responding. It's responding with its IP address, it's responding with its host name, and it's counting. If I repeat this, it keeps counting. And not sure what you think about the counting. Probably you think that's German engineering. Now, let's try and find out why is it doing that. We can check the log files with Docker logs. And now I need the ID of the container, which is printed here. So I need to get this whole ID. I don't need to get all of this. I just have to have it unique. So let's look at the log files. And if you see this, what happens is these are the requests, these are the requests that I send by hitting it with the browser. And then it tries to get the fav icon, this little thing here. This is what the browser does. And this is why we are counting like 2 invocations if I click once in a browser. The other thing is, if I do a curl, you see it says 12. And if I do a curl again, it says 13, 14, 15, and so on. So it's counting okay if I really hit it directly without the browser. Now, if you want to have more insight into this container, I can look into this container. I say Docker, execute. I want a terminal. It should be interactive. And I need the same container again, which is this 1A5. So I say 1A. And I want to run a shell. Now I'm in the container. And in the container, I want to compare this being in the container with another terminal. Let's make this a little bit taller. It's not resizing. Okay, anyway, this is not too important. It's more important that you see this. Now, in the container, you see, surprisingly, there is only 3 processes running. There is this little web server running that I was showing you. There's the shell running that I need to peek into the container. And there is the top running that I'm doing right now. So there is a file system in this container. And there is a whole network stack. So if I say if config -a, you see that there is a network. And if I ping some address from a server that is running under my desk in Germany, it's fully connected to the network. So this is all, so far this container seems a little bit almost like a VirtualBox instance now. And a lot of people say, what's the real difference? The real difference, and part of the magic that is done with the namespaces, comes if let's try something. If I get another shell that is also running on the cloud. Now, if I look here for the same process, if I grab for web server, you see the same process I can see on the cloud instance outside of the container. So this is in the container. If I do the top, I see the web server running, and this is outside of the container, which is not at all like a VirtualBox image now. Now, if I take this process ID, and if I say sudo kill -9, and give it this process ID. Here, still running. If I execute this on the host machine, well, it's gone. So my whole container is gone. And that's the important thing to remember if we talk about isolation versus virtualization. We only have namespaces that help us to isolate those processes. Another thing is if I want to run a command like docker run on this CentOS container, and I want to say something like uptime, those containers, they start up really quickly now. So the uptime of such a container should be very small. If we do this, it says uptime is 2 days. Again, this is one of the limitations that we have for containers, because it's just isolating, but it's not completely booting up another operating system. So this uptime command goes back to the kernel that is running on the Amazon Linux. So I think you get a feeling about those namespaces and about isolation. The C groups are a bit more difficult to show, but if I say docker run and look for the help file, and I say grab CPU, you see the switch that I could provide for running such a container that would limit the CPU resources. And the same is obviously working with the memory limits that I could set here for a container. So we understand the namespaces for isolation. We understand the C groups for setting resource limits. The other thing that I like to emphasize is if you look at my container, and that's the one I was just running, this micro container, it's 8 megabyte in size. So it's incredibly small. If you do a JDK download, it's like 20 times bigger than this container. And well, you've already seen the trick. It's not running JDK, it's not running Java, it's running a static Python binary and then executing this little web server. Okay, so we understand about those C groups as well, and we see the size of those containers. Now going back to the command where I started the container, it was this one. And let's talk about scalability. And maybe you have to help me with this. This is, oops. This involves some coding. Let's try and start more than one container. Let's start maybe 3 containers or 2 containers. And let's do this. Now the port mapping here, it won't work if I run 2 containers with this loop. So I replace the -p with a capital P, and the capital P, well, means do the port mapping, but I don't really care about which port you map it onto. So if my bash scripting is good enough, this should start as 2 containers. Good or not? Cool or not? You don't look too impressed. How many virtual box instances did you ever start on one machine? 2, 3, 4? You say 2? Okay, I try to beat your virtual box instances. And I want to start like, how about 1 container for each of you? We have 200 seats. There is 30 people standing around here. How about 230 containers? Let's look at this. Now, ladies and gentlemen, this is actually happening. Every line that you see is the ID of a container that is starting up. You can count like 21, 22, 23. It's a synchronous call because it's my for loop. So I can start maybe 3 containers in 1 second. And you've never started that many, well, VirtualBox instances on one machine. Now, that's a big difference if you still don't really think it is a big difference between having virtualization where you boot an operating system and just running containers. So we understand about scaling. We've seen the size. We understand about C groups and the namespaces. That's most important. That's all you need to know about containers. Then you have the basics. And then let me change here and just say Docker PS. You see all those containers running. And if I say Docker PS and count the output, it's 122, 329. So they will all be starting up. Now, what if something goes wrong? The answer is it's running in the cloud. I don't really care. This is why I want to use the cloud now to run those experiments in a quick way and in a cheap way. If it fails, I would just shut down the machine. That's why I'm not doing it on my laptop, because I still need my laptop for the PowerPoints. Talking about PowerPoints, let me switch back to the slides. And let's talk about microservices, because this is most often what we want to do now these days. We want to run microservices. We want to implement the microservices architecture. And the first question, obviously, is what are microservices? And there's a pretty good definition that comes from Martin Fowler. And he says it's a suite of small services. They all run in their own process, and they own their own data. That is very important. And they communicate with each other using a lightweight mechanism. I think Martin Fowler is one of the experts if you talk about microservices. Who's the guy that we probably most often associate with microservices that was really pushing this in IT? Any names? Well, I think it's Adrian Cograft. He was pushing this in Netflix. So this was the first company where I took note of that they're really going for a microservices architecture. What I want to do is I want to show you like a 1:30 statement that Adrian Cograft was doing on video, talking about the problems, how we get to microservices, and what were the reasons why we couldn't have microservices like 5 or 10 years ago. It's a short video, 1 minute. We watch it together. Then I tell you a little bit more about other restrictions. and then we see about how can we really implement those microservices.
Come up with a series of animations, each illustrating a specific concept. So this talks on the evolution of business logic as we went from monoliths through microservices, and now we're looking at functions. Back about 10 years ago, we had monoliths, and when we tried to split them up, we found that it was a lot of hard work. The networks were too slow, the CPUs were too slow, and the messaging protocols we used were based on XML and SOAP, and they were heavyweight. So when we tried to split things up, we ended up with fairly large services which had a lot of functionality in them, and we had a relatively small number of monolithic services that we built out. Moving forward a bit, what we found was that CPUs got a lot faster, networks got a lot faster, and we moved to much more efficient protocols. So it's maybe 100 or 1,000 times more efficient now to make calls between services. That let us take our monolithic services and break them up into microservices. Those services form a fairly complex looking network with a lot of messages flowing backwards and forwards between them. You can see here a service network and service mesh where we go from the edge, we flow through many layers of services to reach, on the right-hand side, storage services and caches. Now we take that environment, we think about the way that these services are becoming more standardized. So rather than building all these services ourselves, we're starting to use off-the-shelf services that are scaled, they're highly available, and they come from AWS. So we have SQS, DynamoDB, Kinesis, SNS, and S3, and we feed them all from the API gateway. The microservices that we built in between these provide is where the business logic lives. So if we look at that business logic, that's the glue between the bricks. And we're now starting to split that glue up and form individual functions that are really just connecting these services. And I've drawn this grayed out because they're not actually running until there's some work for them to do. You get a request coming in on the gateway, and it gets routed through a few functions and finds its way to a particular set of services.
Okay, I think this was a really good explanation about some of the problems that we faced for building microservices that I put here in the middle under hardware and networks. So it's like the network protocols that we use, the CPU speed and network bandwidth and latency. There is more to it. If you look at the left-hand side, what I put under software architecture is the question, if you go for containers, if you run your microservices in a container like I did, how do you run those containers across hosts? The other question is, if you have a data store per microservice, you're probably facing running a lot of databases. So maybe some microservices do better with a relational database. Other microservices, they do better with a NoSQL database. And maybe other services do better with a graph database. And somebody has to run and operate and patch all those databases. And then if you look on the right-hand side, what I put under tools is if you need to build and deploy this, probably your Maven package deploy doesn't cut it anymore because now you have to deal with dozens of services. So all this microservices strategy, cutting a monolith into microservices, in my opinion, increases the demand for other services like lower level infrastructure services that you can either operate yourself, which requires a lot of knowledge and probably people, or you can use cloud services to have them running. This is why I think this is another reason why you probably want to run your microservices in the cloud. So apart from these technical challenges, we face organizational challenges. Now, hands up, who has ever heard of Conways Law? That's maybe 20% of you. So Conway once said, and to be honest, I didn't believe this at the beginning, and then I was in many projects, and now I strongly believe this. So Mr. Conway once said that if you build software in an organization, the structure of the software will resemble the communication structure of your organization. That means if you're building software in a highly hierarchical, big organization, you probably end up with a monolith. Now, understanding this, the real question is, what can you do? I mean, what if you want to do microservices, but you're this big, monolithic, big hierarchical software company? And even fewer people know about this inverse Conway maneuver that basically says, well, then you have to adapt your organization, first of all, and have smaller teams that are independent from each other, that work independently and work in a more agile way. And this is the only way to build a good microservices architecture. And this is what we do at Amazon, and you probably heard of those two pizza teams. Now, having said that, let's talk about running containers at scale. Now, I did this already with my for loop, didn't I? Well, I didn't, to be honest. That's not really running containers at scale. This is just showing you scalability of containers on one host. But it's not running containers at scale. So what can you do? The answer is, since the very beginning, we had customers running Docker on AC2. That's exactly what I did for you to show you. But there were pain points. And actually, these pain points are exactly where I stopped with my demonstration. And I'm not afraid to tell you this because many presentations, they stop right here. But we start here and we talk about those pain points. Like, how about scheduling? How about placing those containers, managing and deploying them? All this is really difficult, and I didn't show you this in this live demo. So our customers wanted something that helped them to overcome those pain points. So managing containers at scale is hard. Containers are a good solution for our microservices architecture, but then managing those containers at scale becomes incredibly hard. If you think about you're running like 29 containers already and you need to place container number 30, which would be the adequate host with the best resources to put it. That's nothing that you can decide easily. Oops. Those containers, I've shown you how quickly they can disappear. Simple kill or something else, a memory thing could make them disappear. How do you deal with this? And then having such an orchestration system around those containers at scale, again, is complex. And we need to understand this. So to cope with this, we built ECS for you. It's Elastic Container Service, and it's a highly scalable container management system or container orchestration system. It does cluster management, and it comes with a deep integration into other AWS services. And you can use load balancers that work on a container level. And probably, and that's one of the core messages here, this is the easiest way to run your containers at scale in the Amazon cloud. So that's something to remember. On a more technical level, it looks like this. We have those EC2 instances that you see in the middle. On those EC2 instances, we have tasks running based on a task definition. And such a task definition is a blueprint for your application. Each time you launch such a task on Amazon ECS, you specify a task definition, and you specify which container you want to run, how many instances you need, what is the port mapping. Remember my -P999, exactly this, and other parameters. So this is what you specify. And there is also an ECS agent running on our EC2 instances. And this ECS agent is starting and stopping the containers, and it's communicating with Amazon ECS. And actually, this ECS agent is open source. So if you want to use it, you can build your own orchestration system around it. I don't really recommend it because it's a very laborsome task. But in theory, you could do this. Now, a lot of people are using this system, and some people reported back to us, well, this is good, this is solid, it makes a lot of sense, and we enjoy the tight integration to other Amazon services. But it's also the thing that they have to manage the EC2 instances bothered some people. And they said, wouldn't it be cool to have less control over those EC2 instances, and couldn't you manage them for us? It's your choice. It could be a good thing that you are in control of those EC2 instances. You can select, the size, you can select the type, you could use a Windows instance, so all this is your control. But some customers says, no, I don't want this. All I want to do is run my containers. And this is why going the wrong way. And this is why we built Fargate for you. Now, The important thing about Fargate to know is that it's not really a service that you will find in the AWS console. It's a launch type. So if you decide to go for ECS, you can also decide to go for Fargate, and then we do the management of the underlying hosts for you. And this is what a lot of people want. So I'm a big fan of containers, but I don't really want to manage those hosts. I want to start and run my containers. So you give it a task definition, you set the resource limits for this task, and that's it. Off you go. And that's a really good solution for a lot of customers. Now, having explained this again, it's you choose ECS, you choose the orchestration tool. There is a second one, and I will come to this in a minute, and then you choose the launch type. You go for EC2, you bring the worker nodes, you care about your EC2 instances, or you switch to Fargate, you say, I want Fargate launch type, and then we provision this for you, and all you do is run your containers within the specified resource limits. There's a second service that I will talk about. It's called EKS, Elastic Container Service for Kubernetes. And also for this service, you can choose between bringing your instances yourself, the EC2 instances, and in the future, it's announced, it's not available yet, you will be able to choose for Fargate as well, and then we do the management of those nodes. Now, the question is ECS used a lot? And the answer is yes. We have actually very big customers using, now I'm stuck here. I don't really know why. Oh my God. Let's try and get out of this. Maybe it's gone. Let's see. Yeah, okay, so Segment is a company working with startup marketing data, and they process more than 250,000 of events per second, and that's a huge number, and they run on ECS almost entirely, and they have auto-scaling enabled for ECS, so they scale up to thousands of nodes in one cluster. Now, this actually could be the shortest presentation here ever, half an hour, happy days, because we have a good solution for running your containers at scale. And I already told you that it's probably the easiest solution that we can offer. But then there was something that's called Kubernetes. Kubernetes showed up, and the DevOps, developers, operating people, they love Kubernetes. Now, imagine this. We have this perfectly well-working system called ECS, and people say, oh, there is this fancy new thing, and we like it a lot. What would you do? Well, we built EKS, which is the Elastic Container Service for Kubernetes. And the first question, obviously, is what is Kubernetes, and why should you care about Kubernetes? So Kubernetes is an open source project that is moving a lot. There is people with a lot of enthusiasm behind. It's an ideal platform for running your microservices at scale. I will present you a customer later that is using EKS a lot, and he literally said, this is software that is so good that it's hard to imagine you couldn't even buy this for money several years ago. So there's a huge enthusiasm behind Kubernetes. It offers a powerful abstraction layer for managing containerized infrastructure. If you start with Kubernetes, the first commands is you want to understand about all those Kubernetes resources like pods, like services, like deployments, like ingress controllers. And then after a while, you understand the power of Kubernetes, that it's a single extensible API where you can easily add more, components and more functionality. So we had customers running Kubernetes on EC2. Same as you can run Docker on EC2. But those customers, they told us, well, please run Kubernetes for us. Running Kubernetes is not easy, to be honest. It's not easy. So we built EKS, which is the managed Kubernetes platform that we can offer you. And basically, there is two parts to it. The top part is the master node. And we hide this master node, including all the complexity, all the steps that we need to do behind a fully qualified domain name. So you speak to the API server of Kubernetes, which is a logical DNS name. Now, we want you to run enterprise-grade workloads on Kubernetes. And this is obviously why we have to make sure that this master node is highly available. And to make it highly available, the part of the master node that is keeping the state is called etcd. And this is why we have to provision etcd in a way that it's highly available. And that's what we do. We provision it multi-availability zone. That means there are copies running on at least three different data centers. We scale the instances where etcd is running accordingly. We give it provisioned IOPS. We run backups. And if something goes wrong, of course, we restore it. So it's really to run enterprise-grade applications on top of Kubernetes. And all you see from this is this fully qualified domain name that you talk to it. Now, looking at the worker nodes, same story again. You bring the worker nodes until, well, soon you can use the Fargate mode for this as well. The worker nodes connect to your Kubernetes cluster. And the good news is then you can use all your standard tools like the kubectl and speak to this Kubernetes cluster that is set up for you. It's certified Kubernetes. This is, I think, what everyone expects. I think very few people would say, well, could you tweak it a little bit here and do something there and add some bells and whistles over there? They want a compatible upstream unforked Kubernetes, don't you? That's what I would expect from a company like AWS. At the same time, of course, you want a tight integration to our existing cloud services. And one is IAM for identity and access management. And this is why, together with a partner called Heptio, we built this authenticator. And this is what allows you to use those IAM rules for the role-based access control in Kubernetes. And we built a second plugin for the networking. This is what allows you to use the IP addresses from your VPCs. That allows Kubernetes to use those IP addresses from the VPCs. And that's the CNI plugin. Both are open source. So you can go and look at the source code. And if you want, you can change and modify it. At the end, you get the beloved console that we all know from Kubernetes. You get your kubectl command line that is working as expected. And people say, what's the easiest way to get started? And of course, we describe you how to get started, how you bring the worker nodes, what roles you need to configure, how to connect them. But there is, for beginners, if you want, just focus on Kubernetes. There's a much easier way to get started. It's a tool, it's an open source tool again, which is called EKS control. And all you need to say is EKS control create cluster. And that's it. If you specify the name like I did, you get a proper name. Otherwise, it will pick a funny name, a little bit like Docker does. You know, those Docker containers get a fancy name. And the same is true for EKS control. And if you don't specify the number of nodes, I think the default is 2. So in my opinion, if you want to get started, use this first, and then maybe look into more details if you really want to, if you care about your VPCs, about the subnets, about your IP address ranges, and so on. So that's a good tip to get started. The question is now, we have two choices now. You can go for ECS or you can go for EKS. And a lot of customers say, please, which one should I choose? And I think the answer is not so difficult. If you have both, if you have on-premise workloads and at the same time you have cloud workloads, and if you have some affinity to open source, which is a euphemism here in Kubernetes, if you can cope with, changing systems and quick updates, and if you enjoy those CNCF projects that I will introduce in a minute, and maybe if you already bought into Kubernetes, then use EKS. That's the natural choice. If you want the platform that is most tightly integrated with the AWS cloud, and if you go for very large cluster, like the segment customer that I was introducing you, then go for ECS. Then you can use Fargate or not if you want to if you want to manage the underlying hosts yourself or not. This is the second choice that you have. Now, running your microservices on Kubernetes has a lot of benefits that I was trying to explain, but it brings you even more. And this is, I think, where a lot of DevOps these days look into. And it's called Cloud Native Compute Foundation, or CNCF. And this CNCF, it serves as a vendor-neutral home for many of the fastest growing open source projects. And if you do a lot of open source like I do, you understand there is just too many open source projects typically. And a lot of people say which of them make sense and which of them don't make sense. And this CNCF is a little bit like a safety blanket that tells you we have those incubating projects. They are not perfect, but I think incubating at least requires like three, like that this project is used by 3 different customers in production, but you still should be prepared to, to work a little bit to get it up and running. And then we have those graduated projects, which is Prometheus for time series, and it's Kubernetes itself. And this is like a pre-selection of useful tools or useful projects that you might run on top of your Kubernetes cluster to get additional benefits. And one of the most talked about things these days probably are service meshes. And the question, first of all, what is such a service mesh? The idea of a service mesh is to complement Kubernetes by doing things that Kubernetes is not doing natively. So we have 2 services, a service A and a service B, and they're talking to each other. Now in Kubernetes, in service A, you could just say, I want to talk to service B, and the resolution, the name resolution will make this happen. If we have a service mesh in place, we inject something that is called proxy on each pod. Now this proxy is relatively small. It's 8 megabytes in size, and it's automatically injected. This is one of the extensions. It's called admission controller, and if you enable this extension, in every pod that you start with your containers, there will be this proxy in addition injected. And now this proxy does a little bit like, service buses used to do 10, 15 years ago, where you had this huge layer of a service bus that was dealing with cross-cutting concerns, but it's just split into, as many pieces, as many pods that you're running. So the service communication from service A to service B is going through this proxy. Now, because it's going through this proxy is able to collect all kind of telemetry data, and you can also instruct this proxy to forward the communication maybe to service B version 1 or service B version 2. So all these cross-cutting concerns like retries, versioning, circuit breaker that we used to do with either service bus or sometimes with libraries, these open source cloud libraries that come from Netflix like Hystrix, where we could do it with them. We can do it now with the service mesh. The benefit of using such a service mesh is it's not a library. You don't need to change your source code. That's amazing. And if you have a library like Hystrix for circuit breaking, it's only running for one particular language, and you need to change the source code. With these proxies, it's just happening automatically. You don't change the code. It's working for any language. If you can deploy it into a container, you get this additional benefit of running a service mesh. Now, here's an example what you could do. You could play a little bit of chaos engineering and say, it seems to work well if service A is talking to service B. But what I really want to do is I want to tease it a little bit, to make it more harder, and to inject faults like an additional delay in 10% of all the requests. So 10% of all the requests, you add this extra delay of 5 seconds, and then you see how your client on the service A side is behaving. And that's something that would be hard to do otherwise without changing your application. And there's a whole lot of things that you can do with just applying a little bit of YAML file. So it's 2 things that work together. It's the service mesh that is, for example, Istio. That's one example. And then it's the proxy that is a layer 7 proxy that understands HTTP, HTTP2. It actually even understands in an alpha version the DynamoDB protocol. It understands MongoDB. And it's a small C++ binary that is automatically installed for you in these pods. They both work together. This is typically what we consider service mesh, but they're not tightly coupled. They're not married together. You could replace the Istio service mesh and use something else together with this Envoy proxy. And this Envoy proxy is actually a very cool piece of engineering, in my opinion. And I'm pretty sure that we will talk about this more often. If you install the service mesh, you can install it with a Helm chart. It's one command line. Helm is like a package manager, like the yum that you know under Linux. It's just called Helm for Kubernetes. That's actually another thing that is giving additional benefits to Kubernetes. We have this package manager called Helm. So basically what you say is Helm install Istio. You get all the Istio benefits. And then you give it 3 more switches. And the first one is enabling the open source project, which is called Jaeger, which is giving you flame graphs. If you turn those graphs upside down and you color them red, they look like flames. This is why they're called flame graphs. And they give you a lot of observability into your microservices. Remember the video that I was showing you at the beginning where Adrian Cocroft was talking about all those services interacting? How do you still know what they're doing? How can you visualize this? How can you trace them? And this is one answer. This is the open source answer. There is an AWS service called X-Ray that is doing similar things. So again, you have to compare. Do you want to go the open source way? That is possible because we support it, because we run unforked standard Kubernetes on as EKS, and then you can have those additional tools. Another one is the, I think, very popular Grafana that a lot of people use to display time series. And then there's some smaller things. This is a real example from a demo application that shows you the interactions between those microservices. And that's another thing that would be otherwise hard to get. If you stay within AWS, you could go for AWS X-Ray. That's the cloud equivalent. But sometimes people want to have the same thing on premises and go for the open source solution. And I think it's important that we support this. So I was running this on a EKS cluster just 10 days ago. Right. Do we have customers doing this? Does it sound like this is very far off and nobody's doing it? No. We had Snap on stage talking at the summit in New York, and they were presenting actually exactly this. You can have all the slides. If you let us scan your badges, you can get access to the slides. Then just click on the link, and you will see the technical director of Snap actually talking about, well, how cool Kubernetes is, that this is software that you couldn't buy just a few years ago for all the money that you wanted to spend on it. And then he's explaining why those service meshes, in particular Istio together with Envoy, helped them a lot to, well, to shape their traffic and to do the versioning and so on. Now, to conclude, and we are in time, that's good. To conclude, I think you should architect wisely. Choose between ECS, which might be the easiest solution to run containers at scale, or Kubernetes. If you do Kubernetes, trust me, it's super hard to do it yourself. I was trying this. I built a Raspberry Pi cluster with 4 nodes, and I was practicing everything, and I failed terribly very, very often, and it took me a lot of time to get this up and running. So if you go for Kubernetes, in my opinion, you should definitely go for a managed Kubernetes service like AWS EKS. It's important to understand that this is unforked upstream Kubernetes. We don't want to, well, we want to integrate it to the AWS cloud, but we don't want to change it in a way that makes it non-compatible. And actually, that's quite a challenge, I think, for our service teams, and they do really well. The CNCF project, this is just a nice add-on that you get if you go the Kubernetes ways. A lot of people start, I don't want to say playing with this, but start exploring this. In my opinion, this is a little bit like Kubernetes was in the early days. It's there, it's working, you don't really know how stable it is. A lot of people actually questioned Kubernetes in the early days and said, well, will this ever take over? Will this ever take off? And it did. Now the whole industry now wants to do Kubernetes, and maybe we can expect the same from these CNCF projects. If you install it, you can simply install it using this Helm chart, and this ties you into these other Kubernetes projects with just one additional parameter into Jaeger and Grafana. So the conclusion of my conclusion is that I think you should run your containers in the cloud. Hopefully I could convince you about this. We have a workshop about EKS. It's done by Brent, and he's around here somewhere. I can't see him from here. It's something that I recommend to get started. You have some really good instructions that tell you how to get started with EKS on the Amazon cloud. If we didn't scan your badges yet, consider to let us scan your badges. It will give you my slides and all the other slides. It also gives you $200 in credits for the AWS cloud. Remember that this was the last presentation, but only for today. We will have more tomorrow and the day after tomorrow. I'm Frank Munz on Twitter. Feel free to talk to me. I'm not running away. You've been a great audience. Thank you for being here, and have a nice evening. Thanks.